Hey, what's up, Calculus Classroom? It's your boy, Jake, hitting you with that hot knowledge. We're talking about related rates in this episode. Let's get right down to business. Now you may be asking, Jake, what are related rates? Well, don't you worry. Here you go. Related rates are problems involving at least two changing quantities. You're asked to find the rate at which one quantity is changing, so you use related rates. You give them a formula, you substitute values in, and it's basically use implicit differentiation. You know what's good. Let's check out a problem. Okay, so we have this beautiful retractable SIAM ladder over here, and it's leaning against a wall. We got the bottom of the ladder securely bolted to the ground 10 feet away from the wall. Now the ladder is falling down the wall at a rate of 0.5 feet per second, at a height of 5 feet from the ground. What is the rate of change of the ladder's retractability? Now, let's figure out what we've been given here. We've been given our base length, which is 10 feet. We've also been given the rate of change of the base, because if it's bolted to the ground, I don't think it's going to change. So therefore, it's going to be 0. Now, what else do we know? We know the height of the ladder at the time, which is 5 feet. We also know the rate of change for the height, which is also going to be negative 0.5 feet per second. You know why it's negative? Because it is decreasing. So, what do we have to find? We got to find what the height actually is, so like the length of the hypotenuse, and we also got to find the rate of change of the length of the hypotenuse. That's a lot of words, so let's just get right into solving. Alright, so we've set up our beautiful equation to find out the length of a triangle. I'm going to shimmy it over to the side down here to substitute in values. How do you find the hypotenuse of a triangle? It's x squared plus y squared is equal to z squared. We know that y is going to be 5, so it's 5 squared, plus x, which is 10 squared, is equal to 125. Well, So now we got to figure out what the square root of 125 is, because, z squared is equal to 125. If you guys didn't feel like solving that, it is going to be 5 root 5. So we go back up here. Now, you know what we thought we were going to do? We're just going to derive both sides, because, who doesn't want to derive things in calculus? Am I right, guys? That's what I like to hear. So, now we got to substitute in the values we know. We already said before that dx over dt is going to be 0. We also said that x is going to be 10, so it's just basically 0 times 2 times 10. Anything multiplied by 0, it's going to be a hot 0, so we're just going to leave that be. So we know y is going to be 5, so let's just substitute that puppy right in there. And dy over dt, well, we know that's negative 0.5, so let's just substitute that in there. And now, this is where it gets really tricky. We only know z. We don't know dz over dt, so just substitute in 5 root 5 for z. So, once you multiply everything out and you put everything in place, you get negative 5 is equal to 10 root 5 dz dt. Now, ladies and gentlemen, we're trying to find dz over dt, so you're going to divide negative 5 by 10 root 5, and what you're left with is negative 1 over 2 root 5. How do you interpret this answer, you may ask? Well, the height of the ladder is decreasing at a rate of negative 1 over 2 root 5 inches per minute. Inches. Okay, thank you. So let's get right into the next problem. Wha-bam. Ice cream. Ice cream. Okay. An ice cream cone is spilling with melted ice cream at a rate of 3 inches per minute because you're a slacker and you can't eat ice cream correctly. The radius is changing at a rate of 1 inch, ladies and gentlemen, per minute. What is the rate of change of the volume of the cone when the height of the melted ice cream is 30 inches? This is a little tough, so we got a beautiful licorice font of the work. What do we know for this equation? Well, we already know the rate of change of the height is 3 inches per minute. We know the rate of change of the radius is 1 inch per minute, but we don't know the change in volume. That's what we're trying to find out. Now, we know the volume formula for a cone is going to be 1/3 pi times radius squared times the height. Now you may be wondering, Oi, Jake, what's the radius of this cone? Well, let me hit you with that hot ratio. We also know the height is going to be 30 inches at this time, so we set up the ratio 54 inches over 12 inches, as we've been told from the initial equation, height over radius, is equal to 30 inches, which is the new height, over the new radius. So when you set up this equation and you substitute and you do all your magical math stuff, you get 9x is equal to 60, or x, which is equal to r, which is equal to 20 over 3. So that's going to be your radius. So we go back right into our main equation, and you're going to want to do what's known as deriving it. And you may be also wondering, oi Jake, how do you derive something with two variables? I'm going to tell you how to derive something with two variables. You use the product rule. Oh my god, product rule. So when the product rule makes its appearance, what you're going to have is dv over dt is equal to 1/3 pi, because those two are constants, you can just pull those out there real quick, is equal to 1/3 pi times 2r times dr dt multiplied by height plus r squared times dh over dt. Now, if you want to simplify this, you can, but I'm going to just substitute in everything. So you're left with dv over dt is equal to 1/3 pi times 2 times the radius, which is 20 over 3, times 1, because that's the rate of change of the height, times 30, which is actually the height, as you can see, plus 20 over 3 squared, because it's the radius, times 3. When you simplify that beautiful work, you get 1600 pi over 9. If you didn't want to simplify that, well, lucky for you, we didn't either. We brought in our calculator friend, and we got 558.51 is the change in volume. Thank you for listening, ladies and gentlemen. I have been your host, Jake. These slides were made by Nick and Taylor, and we appreciate your time. Thank you for watching. Next time on Calculus BC Productions, Lagrange James.